Welcome dear students. Till now we completed two chapters of mathematics 1. First one is a linear equation in two variables and the second one is a quadratic equation. Now we have to start with the third chapter of maths 1, that is arithmetic progression. Before going to the arithmetic progression, dear student, in our daily life, if you observe carefully, we see the patterns or we see the sequence. If we take the example of flowers, the arrangement of flowers is in a specific manner, it is in a specific pattern. Arrangement of a honeycomb, if we observe the honeycomb, in that also there is a specific arrangement of honeycombs. And if you see the structure of a pineapple, the pineapple arrangement of leaves, that is also very beautiful because of the pattern or the sequence. That means each petals of a flower is arranged in a specific manner. In each arrangement is this arrangement or this pattern makes the nature beautiful. Like this, in maths also there is a patterns in the numbers. All of you aware about that, but that you don't know what is that pattern. When you start learning mathematics, at that time, from that time, you know that patterns, and that patterns makes maths beautiful. Now we have to learn about these patterns, and that patterns is known as a arithmetic progression. Just now I told you that when you start learning mathematics, at that time you start learning numbers 1, 2, 3, 4, 5, 6, like this. That means these numbers, you know that after number 2 there is a 3, there is a 4, after 4 there is a 5. Like this, these numbers are arranged in a sequence. After that you learn about the tables 2, 4, then here it is like this. This is the table of 2. In this table of 2, there is a first number is a 2, second is a 4, 8, 16, 20, like this. That means you know after 20 there will be a 25. That means these numbers are arranged in a sequence. There is one property that depending upon that property we arrange these numbers. And when a set of numbers are arranged in a specific pattern by using specific rule, then that arrangement of a numbers or the set of a numbers which are arranged in a particular pattern or by using particular rule, then that arrangement of a numbers or the set of a numbers are called as a sequence. Now see, observe this sequence. Some sequences I have written on this board. Here it is 1, then it is 2, 4, 7, 11, 15, 21 and so on. Then here it is 2, 4, 8, 16, 32, 64, like this. This arrangement have a specific order. That means if we observe here, this one, after 1 there is a 2, after 2 there is a 4, and after 4 there is a 7. And if we observe here, after 1 there is a 2, that means in this one we add 1, then we get here 2. And for getting this 4, we have to add 2 in this 2. For getting 7, here it is 3, here it is 4. That means difference between these 2, 1 and 2 is 1. Then here it is 2 and 4, it is 2. 4 and 7, it is 3. And 7 and 11, it is 4. Like this, if we have to find out, see here difference is 5, here difference is 6, here difference will be a 7. That means we can find out the next number easily when we observe the relation between the numbers, relation between the order of the numbers. Now see here, if we observe this 2, 4, 8, 16, that means here it is, we make the double of this 2, we make the double of this 4, we make the double of 8. Like this, there is some sequence, there is some pattern between this number, and when the numbers of a set of numbers are arranged with the specific number, then it is called as a sequence. Here the number of difference between this, if we take out the difference between this 2 and 4, it is 2, 4 and 8, it is 4, 8 and 16, it is 8. Like this, if we make the doubles, then we will get the next number. Suppose we see this arrangement of numbers. In this arrangement of numbers, if we add 10 in 5, then we get here 15. In this 15, if we add 20, then we get here 35. And if we add 30 in this 35, then we get here 65. Dear student, if we have to find out the next number, then we have to must add the 40 in the 65, then we will get the next number. That means there is a definitely at the place of 5, there is a definitely which number we can find out. Why we can find out it? Because there in this arrangement of numbers, or in this arrangement, there is a specific rule is followed. Suppose here 1 and 0, 0 and 1, 1 and 0. Here we can write here 1, then after that is 0. Like this, these are the arrangement of numbers. And in a arrangement of numbers, or if set of numbers is given and that numbers are arranged by using a specific rule, then that arrangement of numbers is called as a sequence. Now all of you understand the sequence. These numbers you learn from at the beginning when you start with learning the maths. These are also a sequence. 2, 4, 8, 16, like this. This is arrangement. Any tables, arrangement of a table 3, like this. This is the table of 3. This table of 3 is also a sequence. Like this, I write here some sequences again. See in these sequences 1, 2, 3, 4 and 5. Now tell me what will be the next number. In this case, if we have to find out the next number, we can easily find out. It will be a 6. Then it will be a 7, then it will be 8. Like this we can arrange the numbers. Now in this case, how can we find out it? See here, if we take out this 1, after 1 there is a 2, that means the difference between this, that means for getting 2 we add 1 in the previous number. For getting this 3, we add 1 in the previous number. Here also it is 1, here also it is 1. That means the one number is added in the previous one to get the next number. For getting the next number, I add 1 in the 5. For getting the 7, I add 1 in a 6. Like this. Now if we observe the second sequence, in this sequence, if I first term or the first number is a 5, second number written over is a 10. If I for getting 10, I add 5. That means 5 plus 5. Here for getting 15, I add 5 in this 10. Here it is 5. Like this. That means for getting each number, I add a particular number every time. For getting next number, to find out the next number, I have to add 5 in this 25. I will get 30. For getting after 30, which number will be there? For that purpose, I have to add 5 in that 30. That means here 5 is a constant number which is added in the previous number. Now see here 1, 3, 5, 7, 9 and 11. Here difference is 2. Here difference is 2. Here difference is 2, 2, 2. Like this. Now see here 1 and 4. Here it is 3. 4 and 7. Here it is 3. 7 and 10. It is 3. It is 3. Can we find out the next number? Yes, definitely it will be a 16. How we will get this? For getting 16, I add a constant number, that 3 constant number in the previous number. Suppose I have to find out the next number, I must have to add 3 in this 16, then we will get 19. That means all these sequences I have written, they followed a specific rule. In this also they are following a specific rule. But here, if we observe these two parts, here the difference is constant. That is, one number is a constant which is added in every previous number. Here 5 is a constant number. Here first we add 1, here we add 2, here we add 3. like this the number is increasing by 1 every time. Here the difference is 2, then it is 4, then it is 8, then it is 16, like this. The number is not constant here. Here 10, then 20, 30, 40, like this. That means all these are the sequences, and sequences, all of you know the sequences. In the sequences, the numbers are arranged in a particular pattern by using particular pattern, and in that pattern is called as a sequence. They have follow a specific rule. But when there is a difference between this arrangement on this sequence and this sequence, in these sequences the difference between the two consecutive term is constant everywhere, and such type of a sequences are called as a progression, and this type of a progression is called as a arithmetic progression. Dear student, this year you have to learn only the arithmetic progression. There is geometric progression and harmonic progression. Two progressions are also there. You have to learn later on about that, but this year you have to learn arithmetic progression. Now everyone understood about the sequences. Now what is the difference between this sequence and this sequence, that also I clear you. And these sequences are called as a arithmetic progression. That is also known as a AP, A for arithmetic and P for the progression. Now some basic concept I want to tell you here. Here see, observe, in this arrangement this number is at the first place, therefore it is called as a, these are called as a terms. These are called as a terms. In this the T first position, therefore this is called as a T1. Then here it is T2, this is called as a T3, that is first term, second term, third term, like this. These are the numbers which are arranged in a particular manner, and that particular manner have a difference, is a constant difference between the two consecutive terms. Dear student, remember this, the difference between two consecutive terms. We have to find out the difference between 2 and 3. We did not have to find out the distance 2 and 4. 2 and 3 are the consecutive terms, and therefore we have to find out the difference between the two consecutive terms, and the difference between two consecutive terms remain constant every time. Then that arrangement of a numbers or that sequence is called as a arithmetic progression. In this case, dear student, this number is known as a T1, then T2, T3, like this. There are n terms, therefore we can write it as a Tn. Now see here, in this case this common difference is difference between two consecutive terms is a 1. Now difference between these two consecutive terms is a 5. Difference between this consecutive term is a 2, and difference between two consecutive terms is a 3. It remains constant every time, and therefore this is called as a common difference. This is called as a common difference. See here, in a arithmetic progression, first of all we have to learn about the term. There are many terms. First term we denote by T1, second with T1, T3, like this. There are Tn. Suppose I write here 2, 4, 6, 8 and so on. Suppose I have to write the fourth term, then I use the T4, and the fourth term is 8, like this we can write. Now the next concept regarding this is we have to find out the difference, and this difference is known as a common difference. The difference is known as a common difference, and it is denoted by the letter D. It is denoted by small letter D. The terms, in this case the first term is denoted by T1. It is also denoted by a small letter A. Dear student, while in arithmetic progression the terms are denoted by T1, T2, T3, T4, like this, Tn, and the first term is denoted by T1. It is also denoted by a small letter. Then the next term is a common difference, and that common difference is denoted by the small letter d. Now see here, we have to learn about the common difference. Now here common difference is a 5, here it is common difference is a 2, and common difference is a 3. Here it is common difference is a 3. Now if the sequence is given, and how to find out the common difference? See here, to find out the common difference, what we have to follow? We have to find out T2 minus T1. That means from the next term we have to minus the previous term, that is second term. From the second term we have to subtract the first term, that is T2 minus T1. Suppose T3 minus T2. Like this we can find out the common difference between the between the two consecutive terms, and this common difference is remain constant between two consecutive terms. Then that arrangement of number or that sequence is called as a arithmetic progression. Dear student, T in book it is given to find out Tn minus 1 minus Tn. That means to find out the common difference, it is given Tn plus 1 minus Tn. That means see, it is same like this, but it is given in another pattern. Suppose it is T. Suppose I write here n is a 3, then 3 plus 1 minus T3, therefore T4 minus T3. It is not different thing, but it is the same, which is given in a different manner. Therefore remember, when we have to find out the difference between the two terms, we have to subtract the next term from the previous term, that is T2 minus T1. We have T4 minus T3, T5 minus T4, like this. In the book it is given Tn plus 1 term minus Tn term. This is the next term and this is the previous term. From the next term we have to subtract the previous term. This and this are the same thing. Suppose I write here 2 plus 1, and here n is equal to 2, therefore it is T3 minus T2. Therefore remember this, when we have to find out the common difference, then we have to make the like this: T2 minus T1, T3 minus T2, T4 minus T3, T5 minus T4, like this. Or we can use this formula Tn plus 1 minus Tn. Now this common difference is maybe a positive number, it may be a negative number, or it may be a 0. Suppose I write one sequence 5, 5, 5, 5. Now tell me the common difference. Common difference means 5 minus 5 is 0, 5 minus 5 is 0, 5 minus 5 it is 0. Therefore the common difference, that is the value of d, it may be a positive, it may be a negative, or it may be a 0. Therefore I think everyone understood what is arithmetic progression. Arithmetic progression, harmonic progression, and geometric progression are the three parts. This year we have to learn only the arithmetic progression. In arithmetic progression, the difference between two consecutive terms is remain constant, and if it is constant, then it is called as a arithmetic progression. The terms are called as a T1. First term is denoted by T1, or it is also denoted by A. Then common difference will be a D. Now dear students, suppose we have to find out, we have to find out the terms in a sequence, terms in a arithmetic progression. Suppose we know the first term T1 is equal to A, T1 is A, and common difference is a D. Then the first term will be a, and what will be the second term? Second term will be, that means we have to find out T2. For finding out T2, what we have to do? We have to do A plus this common difference D. That means when T1 is a, then T2 will be a plus D when D is a common difference. Now we have to find out T3. Then T3 will be a T2 plus D. Now what is T2? T2 means A plus D plus this common difference, that is D, therefore A plus 2D. That means when A is a first term, D is a common difference, then that sequence will be A, then A plus D is the second term, then A plus 2D is the third term. Can we find out? Tell me the T4. T4 will be a T3 plus D. Now what is T3? T3 is a plus 2D, and in that we have to add this T, therefore it is A plus 3D. Got it? Therefore we can find out any term of a sequence by using this. If we know the common difference and the first term, we can write down the any arithmetic progression. Now dear student, on a page number 59, let's remember is given in that in a sequence, if difference Tn plus 1 minus Tn is constant, then the sequence is called an arithmetic progression. I have told you that we have to use T2 minus T1, T3 minus T1, same is given, that is Tn plus 1 minus Tn is constant. That means the difference between two consecutive terms is constant. Then the second one is given in AP, the difference between two consecutive terms is constant and is denoted by small d. See, the difference between two consecutive terms is constant, then it is denoted by d. The difference d can be positive, negative or 0. I have told you that the difference d can be positive, negative or 0. And the fourth one is there, in an AP, if the first term is a and the common difference is a d, then the term in a sequences are a plus d, a plus 2d, a plus 3d and so on. Dear student, write down this table, let's remember page number 59 is given, that is let's remember 4 points are given, and that 4 points you have to write it in your notebook. Now based upon this, today we have to start with practice set 3.1. Dear student, practice set 3.1, question number first. Which of the following sequences are AP? If they are AP, find the common difference. See the question again. Some sequences are given and we have to find out whether they are AP or not. If they are AP, then find out the common difference. First one is 2, 4, 6, 8 and so on. Dear student, we have to decide whether it is an AP or not. For that purpose, first of all, we have to find out common difference. If common difference is constant, that means the difference between two consecutive terms is same, then it is an AP. Therefore, we have to write here T1 first term is 2, T2 is 4, T3 is equal to 6 and T4 is equal to 8. Let's find out the common difference. To find out common difference, we have to subtract T2 minus T1. Now T2 is a 4. Always remember, use the brackets. 4 minus T1, it is 2, and 4 minus 2, it is 2. Then T3 minus T2. Then T3 is a 6 and T2 is a 4. 6 minus 4, it is 2. Then T4 minus T3. T4 is a 8 minus T3 is a 6. 8 minus 6 is a 2. Dear student, the difference between two consecutive terms is a constant. See here. Difference between consecutive term is constant, therefore given sequence is an AP. And common difference is 2. I think everyone understood this. Very easy. Just we have to subtract the next term from the previous term and find out the d. See the seconds. Here t1 is equal to 2, t2 is equal to 5 upon 2, t3 is equal to 3 and t4 is equal to 7 upon 2. I think there is a one correction. Instead of this 7 upon 2, in book there is a 7 upon 3. Make it 7 upon 2. Now see here, we have to subtract t2 minus t1. Now t2 is how much? It is 5 upon 2 minus t1, it is 2 upon 1. Now see here, we have to do the subtraction. Here 2 ones are 2, cross multiply, 5 ones are 5, minus 2 twos are 4. 5 minus 4, it is 1 upon 2. Next t3 minus t2. t3 is a 3 upon 1 minus 5 upon 2. Here use the brackets. Now 2 ones are 2, 2 threes are 6, minus 5 ones are 5, 6 minus 5, it is 1 upon 2. t4 minus t3. t4 is a 7 upon 2 minus t3, it is 3 upon 1. Same thing, 2 ones are 2, 7 ones are 7, 3 twos are 6, it is 1 upon 2. See, the difference between two consecutive terms is a constant, therefore here difference between two therefore given sequence is an AP and common difference is 1 upon 2. Dear student, write down this in your notebook. We will see the next one, that is the third one. Minus 10, minus 6, minus 2, 2 and so on. Then the fourth one is 0.3, 0.33, 0.333 and so on. Now see here, we have to decide whether it is an AP or not. t1 is equal to minus 10, t2 is equal to minus 6, t3 is equal to minus 2, t4 is equal to 2. Now t2 minus t1. t2 is minus 6 minus t1 is minus 10. I told you that use the bracket, that will be easy to solve. It is minus 6 minus minus 10, it is minus 6 and this is plus 10. This minus minus will become plus 10 and it is minus 6 plus 10, it is 4. Then here it is t3 minus t2. t3 is minus 2 minus t2 is minus 6. Same here, minus 2. This minus minus will become plus 6 and here it is 4. And t4 minus t3. t4 is 2 minus t3 is, where it is? It is minus 2. Now say this 2, this minus minus plus 2 and here it is 4. Got it? Now see here, difference between two consecutive term is constant, therefore given sequence is an AP and common difference is 4. Now see the next. T1 is equal to 0.3, T2 is equal to 0.33 and T3 is equal to 0.333. Now see here. T2 minus T1, 0.33 minus 0.3. Dear student, be careful here. 0.33 minus 0.30. Got it? Here it is 3, 0 and 0. Therefore, the difference is 0.03. T3 minus T2. 0.333 minus 0.33. Now see, same thing here. Got it? 0.333 and here it is 0.33. See, 3, 0, 0. Here it is 0.003. Now see, the first T2 minus T1 is 0.03 and T3 minus T2 it is 0.003. That means the difference here dear student, see the difference. Here it is 0.03 and here it is 0.003. Therefore, here difference between two consecutive terms is not same and therefore it is not an AP. Therefore, we can write here difference between two consecutive term is not constant. Therefore, given sequence is not an AP. Try to understand this. How to do the subtraction is important thing in this sum. Let's see the next one. I think I will give you the 6 and 7. See the 6th one. Minus 1 upon 5, minus 1 upon 5, minus 1 upon 5. I think no need to solve this. See here, each term is the same. That means difference between two consecutive terms is 0. Is remains same and therefore this is an AP and the common difference is a 0. I think you can write it very easily. Therefore, I start with the next. That will be a 7th one. 7th one is 3. 3 plus root 2. 3 plus 2 root 2. And here it is 3 plus 3 root 2 and so on. Now see, in this sum, the first term, that is T1 is equal to 3, T2 is equal to 3 plus root 2, T3 is equal to 3 plus 2 root 2 and T4 is equal to 3 plus 3 root 2. See, dear student, T1 is equal to 3, T2 is equal to 3 plus root 2, T3 is equal to 3 plus 2 root 2 and T4 is equal to 3 plus 3 root 2. We have to decide whether given sequence is an AP or not. For that purpose, T2 minus T1. T2 is 3 plus root 2 minus t1, it is 3. Now see here, 3 plus root 2 minus 3. Here it is 3 and this minus 3 will be 0 and answer is a root 2. Now see here, t3 minus t2. t3, it is 3 plus 2 root 2 minus 3 plus root 2. Now see here, this 3 and this plus 3 will be a 0 and here it is 2 root 2 minus root 2. We can write here 3 minus 3 plus 2 root 2 minus root 2. Now 3 minus 3, it is 0 and 2 root 2 minus 1 root 2, it will be a root 2. Try to understand this. This 3 minus 3 and 2 root 2 minus root 2. This minus, therefore this plus will become minus root 2 and 2 root 2 minus 1 root 2, it will be a root 2. Now t4 minus t3. t4 is 3 plus 3 root 2 minus t3 is a 3 plus 2 root 2. Now see, here it is 3 minus 3, this 3 minus 3 plus 3 root 2, this plus will become minus 2 root 2. Now 3 minus 3, it is 0, 3 root 2 minus 2 root 2, it is root 2. Yes student, the difference between two consecutive terms here is same or constant, therefore given sequence is an AP. Common difference D is equal to root 2. See, one last sum is remaining that you have to solve. Very easy, you can solve this. Now we have to start with the next question. Dear student, let's see the second question. Write an AP whose first term is A and common difference is a D in each of the following. Write an AP whose first term is A and common difference D is given. In the first term is a and common difference is a 5 and we have to write an AP. That means we have to write the first term, second term, third term, fourth term. For that purpose, first of all we have to find out the first term. T1 is equal to A is equal to 10. It is the first term, already it is given. Now we have to find out T2. Now T2 means T1 plus D. That means in the previous term we have to add the common difference. Now T1 is a 10 and common difference is a 5. Therefore the 10 plus 5 is 15. Now T3 is equal to T2 plus D. Now T2 is 15 and common difference is a 5. 15 plus 5, it is 20. Then fourth term T4, it is T3 plus D. Now T3 is a 20 and common difference is a 5, it is 25. Like this we can find out the terms. Up to fourth term we have find out. Therefore required AP is first term is 10, second term is 15, third term is 20, 25 and so on. Now see the next one. Second one is very easy, you can solve that. I will show you the third one. Here A common difference is first term A is equal to minus 7 and common difference D is equal to 1 upon 2. Therefore T1 is equal to A is equal to minus 7. then T2 is equal to T1 plus D. Now here T1 means minus 7 plus 1 upon 2. Here it is 7 upon 1 is there, therefore 2 1s are 2 and 7 2s are minus 14 plus 1, therefore it is minus 13 upon 2. Now see here T3 is equal to T2 plus D. Now T2 is minus 13 upon 2 plus common difference is 1 upon 2. Dear student, here it is, base is same, here it is 2, then it is minus 13 plus 1, it is minus 12 upon 2, it is minus 6. If you write minus 12 upon 2, it is also okay. Or if you simplify this, it is minus 6. Now T4 is equal to T3 plus D. Now T3 is minus 6, or we can take minus 12 upon 2 plus common difference is 1 upon 2. Now here it is 2 and minus 12 plus 1, it is minus 11 upon 2. Therefore we find out the fourth term. Therefore required arithmetic progression is, first term is minus 7, second is minus 13 upon 2, minus 12 upon 2 and minus 11 upon 2 and so on. Like this we solve 2. Next we have to solve see the fourth one. See the fourth one. A is equal to minus 1.25 and D is equal to 3. This is the fourth one, and fifth one you can solve. The sixth one is A is equal to minus 19 and D is equal to minus 4. Yes student, see T1 is equal to A is equal to minus 1.25. T2 is equal to A plus D. A means T1. We can write A or we can write here T1 also. T1 plus D. T1 is minus 1.25 plus 3. It is 3.00 minus 1.25. Yes student, do like this. It is 1.75. See here we can get like this. It is 1.75. Now T3 is equal to T2 plus D. Now T2 is 1.75 plus what is D? D it is 3. Then it is 4.75. Now T4 is equal to T3 plus D. T3 is 4.75 plus common difference is 3. It is 7.75. Like this. These are the four terms. Therefore, we can write required arithmetic progression is minus 1.25, 1.75, then 4.75, then 7.75 and so on. Like this we can write an AP. Let's see the next sum, that is sixth one. A first term minus 19, common difference D is equal to minus 4. Now T1 is equal to A is equal to minus 19. Then T2 is equal to T1 plus D. T1, that is A, is minus 19 plus D is equal to minus 4. This minus and this minus will plus, minus 23. Then T3 is equal to T2 plus D. Now T2 is minus 23 plus common difference minus 4, it is minus will plus, it is 27. Then T4 is equal to T3 plus D. T3 is minus 27 plus minus 4 common difference minus 31. Therefore required AP is minus 19, minus 23, minus 27, minus 31 and so on. Yes student, write down all this sum in your notebook. We have to start with question number 3rd. Let's see the third question. Find the first term and common difference of each of the AP. 4 APs are given and we have to find out the first term and the common difference. Dear students, see 5, 1, minus 3 and minus 7. In this case, first term. We have to write the first term. Therefore, first term, that is T1 is equal to A is equal to 5. It is 5. Then common difference. D is equal to T2 minus T1. Now T2 is 1 minus 5. It is minus 4. Therefore D is equal to minus 4. Now see the next. First term, T1 is equal to A is equal to 0.6. Now we have to find out common difference. D is equal to T2 minus T1. Now T2, it is 0.9 minus 0.6. It is 0.3. Therefore D is equal to 0.3. See the third one. It is first term. T1 is equal to A is equal to 127 and common difference. D is equal to, it is T2 minus T1. T2 135 minus 127, it is 8. Therefore D is equal to 8. See the last one, that is fourth one. First term, T1 is equal to A is equal to 1 upon 4. This is the first term. Then common difference. D is equal to T2 minus T1. T2 is 3 upon 4 minus 1 upon 4. It is, denominator is same. Then it is 3 minus 1. It is 2 upon 4. And here it is 1 upon 2. Therefore, common difference upon 2. Dear student, practice set 3.1 is completed. Write down all this sum in your notebook and do the practice of that and solve the related sum which are in a problem set. Thank you.